Okay, welcome to the, I think it's the fourth lesson for today. This is in preparation for your prelims. I'm just touching on the summary. Now the focus is on subtropical anticyclones. I think if I can take you back to the first video. You remember we had a diagram that was like this about the global air circulation. You still remember, where we identified the pressure belts, This is 30 degrees south, 30 degrees north, 60 degrees north, 60 degrees south, 90 degrees south, 90 degrees north. You still remember where we identified these different pressure belts, where this one we said is the low, is the high pressure belts, low and high pressure belts, high, low and high. So what we have done so far is we have talked about the mid latitude, which you find normally between 30 degrees to 60 degrees south and north. Okay, we have also talked about the tropical cyclones, which we said it develops from 5 degrees north and south of the equator to 30 degrees north and south as well. That is our tropical cyclones. Now the focus now is on the subtropical anticyclone. Subtropical anticyclone, this is a high pressure belt, which is a high pressure belt, So we are now focusing now on the subtropical anticyclone, which is a high pressure belt. Hence we have got this topic now, subtropical anticyclone. In anticyclone, I think from what we have covered, you can recall an anticyclone is high pressure. It's a high pressure. What happens in the high pressure? Okay, obviously in the high pressure, just try to make it as simple as possible. There is our high pressure, okay, which means in the inside our pressure cell, let's say here is 1000 hectopascal or millibars, which means as you go outside now, the pressure is lower. Okay, this is hectopascals. Okay, which means that's how you identify your anticyclone, which is high pressure. So it's high in the middle. As you go out, the pressure decreases. We are looking at our isobars, which is the line that shows areas of equal pressure. This shows 100 hectopascals. This is 996, which means that the isobar interval, the difference in terms of pressure height, okay, is what in this instance is 4 hectopascals. Okay, so this is your high pressure. We have also highlighted that in the southern hemisphere, the movement is in an anti-clockwise. This is the way in which moves is an anti-clockwise in the southern hemisphere, and in the northern hemisphere is in the clockwise direction. This is just to re-jog your memory. Okay, so when it comes to subtropical anticyclone, what is it that we should always pay attention to? What is important when it comes to subtropical anticyclone? I think I'm going to take you through, these are general notes that I have here. Location, general characteristics and influence of high pressure cells. So when it comes now to these subtropical anticyclones and how they affect South African weather, the most important thing that you have to do is to identify the different high pressure belts. And in most cases, the one that affects South Africa is your South Atlantic High. You can see this is your South Atlantic High. You find it on the west coast. That is where we have got our Atlantic Ocean. Then you have got our Kalahari High. It's in the interior, which means inside, as you can see. Then you have got our South Indian High is on the east coast. I think you can see. South Atlantic High is causes southwest winds to blow towards the land, responsible for the dry conditions. Why? Because here is emanating from a cold ocean. Cold air by its nature does not hold a lot of moisture. It does not create a mold of moisture. It's cold and dry. That's why you see it's dry conditions along the west coast. Then you have got the Kalahari is emanating from the interior, produce clear skies and dry condition in the interior during winter, because you can see also it's coming from the land. It's located in the land. That's why it's also dry. Okay. And I've got South Indian High, causes northwest winds to blow towards the eastern parts of South Africa, responsible for the rain in eastern South Africa. I'm going to explain this in detail, but this is just to show you the location of different high pressure belts. Where what are anticyclones, areas of subsiding air anti-clockwise in the southern hemisphere? That the explanation I was giving now. Then where are the anticyclones located? In the subtropical high pressure belt named South Atlantic High, South Indian High, and Kalahari High. Okay, you can see from the diagram. Let me take you back to the board. Okay. So you can see from this board, assuming my shape is not that nice, it's not that my shape, my map of South Africa is not that nice, but it's explaining the purpose of this lecture. You can see here, this is where we have got our South Atlantic High on the west coast. I would say this is where we have got our Kalahari High. It's in the interior. This is where we have got our South Indian High. This is on the east coast. As you can see, it affects the weather in the east coast, affects weather on the west coast. So when you are looking at this, you can see it's closer to the Atlantic Ocean, which is a cold ocean. This one you can see is close to the warm oceans. This one you can see is close to the interior. So if you look at it in terms of the wind that blows from these different high pressure systems, they are different in terms of their temperature. They are different in terms of their moisture content, which means the effect that they have on the availability of rainfall or in influencing the climate or the weather conditions within South Africa is different. It is because of where they emanate from. These different air masses that is coming from here, from the Atlantic Ocean, from the Indian Ocean, which is a warm ocean, and also from Kalahari High, which is coming from the interior. So normally what also affects the weather is the position of the Kalahari. It actually shifts. Okay, so in winter you would see that the Kalahari is very active. It's very active. I'm going to give a deep explanation on that one. It's very active in winter, which means there's too much subsidence. There's too much subsidence. The wind that is blowing from both the South Atlantic or that is blowing from the South Indian cannot reach the interior. Why? Because Kalahari is very active. There's too much subsidence. It cannot go above the plateau. So it means if it cannot go above the plateau, then condensation cannot take place. Hence, mostly in winter, you see that rainfall is only received in Cape Town, but not in the interior. Why? Because the Kalahari is active. And also our ITCZ, which is our intertropical convergence zone, it will have shifted to the north. Hence, this is what makes the Kalahari high pressure system to be more active, so that it does not allow either the warm moist air from the South Indian High to reach the interior of South Africa. It cannot go above the escarpment. Hence there's no condensation that takes place to affect the weather or for the interior to receive rainfall, especially in winter. But however, now in summer you can see our Kalahari High is not that active. Why? Because our ITCZ have shifted downwards now, hence it's no longer active, which means our Kalahari moved upwards. Hence now the air from the South Indian High is able to get into the interior. This is what I'm going to explain now, showing how the line of thunderstorms is formed. How the line of thunderstorms forms. Okay, so the first thing is I'm just going to look at these two. At these two, as you can see, this is what I was talking about. During winter, our Kalahari is more active, such that it does not allow this rising, moist that is coming from the sea, rising air that is coming from the sea, to go above the escarpment. It's so active so that there's too much descending air, called descending air, that is blocking this from rising to go above the escarpment. Because the moment it goes above the escarpment, especially if it's blowing from the South Indian High, it results in the formation of reaching condensation, formation of clouds. Then we receive our rainfall. But in this instance now, it is not allowed to go above the escarpment. Why? Because there's too much descendance that is taking place, because our Kalahari High in the interior is very active. That's why you see the presence of the invasion layer. There's too much descending air, hence it cannot go above the escarpment, and there's no rainfall that is received in the interior. The other reason being, as I have already highlighted, that our ATCZ has moved upwards. Okay, but now in summer, as you can see now our Kalahari High is now inactive, it's not that very active. Hence now the warm rising air is able to go above the escarpment, resulting in the formation of rainfall, formation of clouds, and stable weather conditions. I'll take you to the board. Okay, so basically what we are saying now is during what we are saying now is during summer now, we can see we have got this that is coming from the South Atlantic high, and we also have that is coming from the South Indian high moving towards the interior. Okay, so now in summer, our Kalahari is no longer active. It has shifted. It has shifted to the top, and our ITCZ has dropped. This is now within in summer. So what happened? There is now a front that is formed, what we call a moisture front. Here we have got what we call a moisture front. We call this a moisture front. Okay, it's formed. This is the cold air. It's blowing towards the interior. This is the warm, moist air in an anti-clockwise, also blowing towards the interior. Now in summer, because our Kalahari is not active, okay, is not active, this is in summer, which means the warm air and the cold air meets in the interior, separated by a moisture front. This is cold air. This is warm, moist air that is coming from the South Indian high. They are separated by a front. Remember, these two air masses have got different characteristics in terms of their moisture content, in terms of their temperature. So they are separated by a moisture front. So here, since it's cold and dry, hence it sinks. They are drier in clear skies or dry or stable weather conditions that you find on the western side. But on the eastern side, then you will have a line of thunderstorms along the moisture front. We will have what? A line of thunderstorms, okay, on the eastern side along the moisture front. This is where most of the rainfall is received here in summer on the eastern side. Even if you look in terms of rainfall distribution in South Africa, you will find that on the western side there's little or no rainfall that is received, but on the eastern side there's more rainfall that is received, especially in summer. It has something to do with the position of the South Atlantic high, Kalahari high, and also the South Indian high. Like I've said, in summer our Kalahari high is no longer active, which means now we have got the whirlwind that is coming from the South Atlantic high. It's moving towards the interior, and also you've got the warmest air that is coming from the South Indian high moving towards the interior. It's going above the escarpment. When it goes above the escarpment, it results in the formation of clouds. As soon as the clouds are formed, condensation takes place. You've got clouds of vertical extent, which means you've got cumulonimbus clouds. You've got thunderstorms that are taking place, especially on the eastern side. So this one, it undercuts the warm air, is supposed to rise. Formation of a front is already there that separates your cold that is coming from the South Atlantic high and your warm moist that is coming from the South Indian high, separated by a moisture front. And a line of thunderstorms developed on the eastern side. This is your line of thunderstorms. Then we have got the formation of rainfall, thunderstorms, especially development of clouds of vertical extent. But this is in summer. This is in summer. This is what happens in summer. That's where we have got rainfall. Now, the warmest air, as it blows towards the interior, is able now to go above the escarpment. Why? Because the Kalahari is not that active. Okay, the Kalahari is not that active. This is the same thing that I'm explaining. So this is summer. Okay, now the warmest air is able to go above the escarpment. Why? Because there's weaker descending air because of the shifting of the Kalahari. If you look at this diagram, line of thunderstorm, you have got anti-clockwise circulation, South Atlantic high, it blowing towards the interior. There is cold, dry air from southwest is coming from the South Atlantic high. Then you have got the South Indian high, which have got the warm current blowing towards the interior. These two air masses are separated by a moisture front. They are separated by a moisture front, which means they've got different characteristics in terms of their moisture content, in terms of their temperature. Okay, so here along the moisture front, that's where we have got a line of thunderstorm. Warm air rises, condensation, thunderstorms, okay, warm moist air. We are having a line of thunderstorms along the moisture front on the the eastern side, because that's where the warm moist air is coming from the tropics. The warm moist air has got a lot of moisture. As it is forced to rise, it's cooled adiabatically, which means for every 1,000 meters, the temperature drops by 6 to 6.5 degrees Celsius. As it cools, release of latent heat, formation of clouds of vertical extent, then we end up having rainfall in summer. So here is the situation in winter. The Kalahari is very active. There's too much descendants, which means all this air is not going above the escarpment. Hence, there's no rainfall in winter. It's only received in Cape Town, just because the explanation of mid-latitude. But in summer now, we are now saying that the Kalahari has shifted, and also our intertropical convergence zone has also shifted as well down. It has gone down such that it's not active. The rising air can go above the escarpment. What are some of the things that you also need to remember then? A moisture front, a zone between the two air masses with different moisture content, dry air and moist air. Okay, we are saying dry air is coming from the South Atlantic high and moist air is coming from the South Indian high. That's where we have got your moisture front. You have to know what it is. What are the impacts of thunderstorms? Heavy rain and strong winds that can damage the crops, fertile soils eroded, there's loss of incomes, dams filled with water. These are some of the impacts that are also encountered, especially where we've got the line of thunderstorms, especially in summer where the rising air is going above the escarpment. Okay, why do line of thunderstorms occur during winter? During summer, the inversion layer is positioned above the escarpment. Moist air from the Indian Ocean is able to flow in the interior, causing rainfall. I think this is the explanation I was giving just now. There's something also that I need to highlight that is also associated with also that comes with the subtropical anticyclones, the concept of berg winds. Berg winds, normally berg in Afrikaans, it means mountains. I think so. If you're looking now at this diagram, I'm going to use this diagram just to explain. So the first thing that you need to know is what are berg winds and also how do they develop. I think you also need to be aware of that. So these are warm dry winds blowing from the interior to the coast during winter. Remember, in winter, our Kalahari is very active. So it's blowing from the interior where we have got high pressure, normally the Kalahari towards the coast. So you have to make sure when you are defining that you include that part, the warm, dry winds blowing from the interior to the coast during winter. These are dry and warm blowing from the interior is warmed adiabatically, which means for every decrease of 1,000 meters going downwards, the temperature increases also by 6 to 6.5 degrees. Is warmed adiabatically. So warm dry winds blowing from the interior. If you look at your Kalahari here, it's blowing towards the coast. It's blowing toward the coast. You can see this is your high pressure, which is your Kalahari high, is active in winter. Then you can see where you have got your coast level, that is your towards the coast. Okay, that is the low pressure. So the low pressure is at the coast and the high pressure is in the interior, which means our Kalahari high is very active over the interior. This is usually during winter where South Africa do not receive rainfalls. Okay. How does the South African berg winds, okay? Also take note of cross section. You can see it blows from land to sea. So if it's blowing from land to sea, we call it offshore. If it's blowing from sea to land, that's onshore. So which means these are dry and it's also warm. So when it blows from land to the coast now, what happened? What are the impacts of South African berg wind? Mostly veld fires. You can see there are veld fires that are caused at the coast because this is a dry and warm wind. So when it reaches now the coast, the temperatures will have increased. Let's say it started in the interior as 20 degrees. When it reaches the coast, you might find that it will have increased maybe, let's say, to 30 degrees. Let's say from 24 to 30 degrees, which means the temperature are increasing. That's why it's likely to cause veld fires. Mostly veld fires, respiratory problems, animals burned to death, ecosystem destroyed, erosion, pasture destroyed, food insecurity, loss of life, injuries, loss of property. These are the conditions that are associated with berg winds, which means as it blows from the interior where there is higher pressure, usually where our Kalahari high is very active in winter, it blows towards the coast. When it goes to the coast now, we are now saying that it results in all this impact that is of veld fires, animals banned, ecosystem destroyed, pasture destroyed, and so on. How can the impact reduced? The awareness to cause of cigarettes, fire department, firefighters alert, firefighting strategy, irrigate crops to prevent burning. I'm going to sort of draw a diagram so that I can also explain it in a more understandable manner. Okay, I'm going to rub off this. This is our Kalahari High. We get it in the interior. This is our coastal low. Okay, so we are saying now this is the dry wind that is moving from the interior where we have got our Kalahari High. Usually this is in winter. Okay, so we are saying now is this dry wind, that warm wind that is blowing from the interior towards the coast. It's warmed adiabatically. It's warmed adiabatically. It's warmed adiabatically, which means for every decrease of 1,000 meters as it descends, the temperature increases by 6 to 6.5 degrees Celsius. Or for every descent of 100 meters, the temperature increase by 1 degree. So adiabatic warming, which means the temperature increase. The temperature increase. Okay, the temperature increase. When you talk about adiabatic cooling, the temperature drops. Okay, that is the difference between the two. Adiabatic cooling, the temperature drops. Adiabatic, the temperature increases. So in this instance, when we're talking about the baric winds, the temperature is increasing. So it's moving from the interior towards the coastal low. Okay. So what happens is when it's blowing now from the land towards the coast, when it gets now to your coastal low, here is known as the offshore wind. And remember, it's warm and dry. That's why it results in field fires. But now, as it goes, remember it's clockwise. Okay, as it goes now towards the interior, it's now blowing from the sea. It's now blowing from the sea to the land. We call it now onshore wind. We call now onshore wind. It's blowing from the interior, that is your Kalahari High, towards the coastal low. It's offshore because it's dry. It's dry and warm. It's dry and warm. That's your offshore wind. Here, when now it's blowing now from the sea now towards the land, is now warm and moist. It's now warm and moist, okay? It's blowing from the sea towards the land. That's an onshore wind. So if you look at the weather conditions here and the weather conditions there as well, it's not the same. Why? Because of the type of air mass that is blowing in both these areas, okay? It's blowing from the land. This is from land to sea, and is dry and warm. It's warmed adiabatically. Baric winds, mountain winds, which means it's descending. If I'm to take you back to your relief rainfall, I think you can see, let me just put it like this, just a small diagram. Assuming that this is our sea, this is our, okay, I'll put it like this. Normally, when it comes to relief rainfall, what happens? Warm air is forced to rise, it reaches the condensation level, then we have got rainfall on this other side. This is where rainfall is received. But as it goes over there now, it has lost most of its moisture. It's now descending here on the leeward side. This is the windward side. Windward side, okay? More how we explain your relief rainfall. This is your windward side, is forced to rise, reaches condensation level, clouds form, rainfall. But the same air that is rising, it has been cooled adiabatically. We have got rainfall on the windward side. But now, as it goes to the other side of the mountain, it has lost most of its moisture. It's descending, which means, let's take here is where our Kalahari High is. Okay, this is the interior. Let's take it like that. Then it's descending. As it is descending, it is warmed adiabatically, which means if it's 20 degrees Celsius here, the time when it reaches the coast here is gonna be, let's say it's 24 degrees Celsius. Okay, this one of 1,000. Then here is gonna be 30 degrees Celsius. It has been warmed adiabatically. It's coming from the land towards the sea. So you will see now as it reaches here, the temperatures have now increased. It has been warmed adiabatically, resulting in the formation of wildfires like I've explained. So know the positioning of your Kalahari, know the season is winter, it goes up until then this is what takes place. I'm just going to take you through a question that I have here. Okay, this is the question from 2018 November. It's about anticyclones. You can see there is your subtropical anticyclone Kalahari High. There is your South Indian High. Refer to Fig 1.1 shows the anticyclones in South Africa. Choose the word from those given in brackets. Write only the words next to the question numbers. Okay. You can see from the first one, pressure A is situated further. Pressure A, you can see here is going to the top, which means that it's situated further north. You can see that is your South Atlantic High. That is 1.1.1. That is your answer is north. Pressure cell B is named cell B. You can see that is your South Indian High. That is your South Indian High. Remember, South Atlantic High, Kalahari High, South Indian High. That is your pressure B. Then 1.3, which isobars are elongated away from the pressure B as they form A? Okay, if you go to B now, remember it's high, and elongated high pressure gives you a ridge. Elongated low pressure gives you a trough. So the answer there is ridge. The answer there is the ridge. Then 1.1.4, the pressure gradient at C is approximately, if you look at C now, remember it's a higher pressure, which means at the center there is higher pressure, but as you go out, the pressure decreases. The isobar interval of 4, which means from 1012, 13, 14, 15, 16. That's why we have got 1016 hectopascals. That will be your isobar at the pressure reading at 1.1.4. 1.1.5, the wind speed at weather station D is, you go to D, what is shown there, as you can see, that is 10 knots. That is 10 knots. Okay. Then 1.1.6, what is there? The wind direction of weather station D is, you go to station D, what is the wind direction? That is northwest. You can see here, north, south, west, and east. Northwest. That is northwest. Then 1.1.7, pressure cells A, B, and C represent A, B, and C. What do they represent? Pressure cells A, B, and C. That is subtropical high. Remember when I was talking about the pressure belts, I talked about the high pressure belts and low pressure belts as well. So that is the subtropical high. That is your anticyclone, subtropical high. Okay. Then also here, as you can see, this is your subtropical, subatlantic high, Kalahari high. This is your South Indian high as well. I'm just showing some of them. Okay, this is another question as well. As you can see what we have, this is A. You can see with the presence of the tropic, with the mid-latitude here, that shows you that this is winter. Then here you can see cold air front usually misses Cape Town. Why? Because it has moved further down. That's why this one is not winter as well. You can see with what is being shown on the diagram there. Okay, I'm just going to show, this is an example of your bark winds. You can see there is Kalahari High, escarpment, bark wind. You have got your coastal low here. Name the season represented in the diagram. What season? Obviously, it's winter. I've got the answers here. I'll just refer to the answer. It's winter. That is winter. Then give one reason for your answer in question 2.4.1. What will be the reason? Remember, in winter, what happens? The Kalahari is more active. You can also see the presence of Kalahari High in the interior and the coastal low at the coast, low pressure at the coast. What answers do we have? The presence of Kalahari High in the interior, presence of bark winds. Kalahari is close to the surface. I think these are some of the answers that you can give. Then, why is the wind visible in Fig 2.4 known as bark winds? Okay, that is number 2.4.3. Blows from the Kalahari to the low pressure. That's why it's known as bark winds. It blows from the Kalahari to the low pressure at the coastal low. That's why it's known as the Kalahari at the bark wind. Refer to the air movement represented by arrows A to B. Name the resulting local winds associated with the coastal low at B. That is your A. That's an offshore. Remember, it's blowing from the land to the sea. That's an offshore. That's an offshore. This one is blowing from the land to the sea. Then your B, is your onshore. This one is blowing from the sea to the land. That's an onshore. This is an offshore. I've already explained that. Why is the local wind at A associated with dry conditions? A, because it's an offshore. It's dry and warm. Okay? Lengths of moisture, because blows from the land to sea, air subside, no condensation. Then C, in a paragraph of approximately 8 lines, discuss the impact of air movement from the Kalahari High to the coastal low to the physical environment. So paragraph, the impact of air movement for Kalahari from to the coastal low on the physical environment. Remember, the emphasis is on the physical environment. What do we have there? Warm, dry, increases surface water evaporation. It's warm and dry. Warm winds dry out the vegetation. Remember, the emphasis is on the environment. Dry vegetation could facilitate veld fires. The gust winds would fan and spread the fire. Veld fires destroys ecosystems. Biodiversity is reduced. Food chains are disrupted. Destruction of vegetation, soil erosion would decrease soil fertility. The positive raises the temperature of coastal areas in winter. Veld fires encourage regrowth and regeneration of natural vegetation. So these are the answers that you can also give. So I think my lesson for the subtropical anticyclones come to this end. And just to sum it up, so what is it that is important? 3 things are important when it comes to subtropical anticyclones. Number 1, know that the weather of South Africa is affected by the 3 high pressure systems. That is your South Atlantic high, you find it on the west coast. South Indian high, you find it on the east coast. Then your Kalahari high in the interior. Okay, what is it that you must know as well is the movement of the Kalahari high, especially in winter. That's where it's very active because of the movement of the ITCZ in the northern hemisphere. So when the ITCZ moves northwards, it means our Kalahari high is very active. Hence, the rising air that is coming from the South Indian high cannot go above the escarpment. It cannot go, if it cannot go above the escarpment, it means there is no rainfall that is received, especially in winter. That's where our Kalahari high is very active. Okay. In summer now our ITCZ has shifted. It's moving southwards. It means now our Kalahari high shifts as well. It goes upwards. Okay, it's no longer active. So the rising air that is coming from our South Indian high and also from our South Atlantic high is now able to go above the escarpment. When it goes above the escarpment, what happens? The two are separated by a moisture front. The two are separated by a moisture front. Okay, we have got this coming here. This from our South Atlantic high, South Indian high. Okay, this is your moisture front. So this that is coming from the South Atlantic high is dry and what? And cold. This that is coming here from the South Indian high, it's warm and moist. Why? Because of where it is coming from. Okay, so we have got the development of a moisture front that actually separates the dry, cold air and the warm, moist air. Which means where we have got our moisture front, along with that's where we are going to have a line of thunderstorms. Okay, line of thunderstorms. Obviously, more rainfall is received on the eastern side, whereas on the western side there is cold and dry conditions. Why? Because the warm, the dry and cold air does not hold moisture. It's coming from the cold ocean, that is the Atlantic Ocean. It does not hold a lot of moisture here. Hence, we have got clear skies, dry conditions, but on the eastern side, that's where we've got the line of thunderstorms, we've got unstable weather condition. That's what happens there. So in general, know the positioning of your South Atlantic high, positioning of your South Indian high, and also positioning of your Kalahari high, and also how it shifts. In winter, it's more active. There's too much subsidence, which means no air that is rising is going above the escarpment. So there is no rainfall in the interior. Then also another concept that we have talked about, the concept of your berg winds, mountain winds. Know that there is Kalahari high in the interior. There is the coast. At the coast, there is a low pressure system. So the movement of it from the Kalahari high to the coast where there's a low pressure. This is warm and dry winds. Okay, so they cause veld fires, and also no offshore when they're coming from the land to sea. When they're going back from sea to the land, we call them onshore. They've got different weather conditions. So in short, this is your subtropical anticyclones.